Method of data collection recording. Data can be recorded through 3D imaging, which is an example of this is Vicon images, where illuminated markers are attached to an object or body, and cameras all around the room create a 3D image which can be spun and viewed from all angles as it's three-dimensional. The image is generated by a computer and creates a digital image like an avatar on screen. So an example of this would be if a basketballer's jump was being analysed, they would have illuminated markers attached to their body and cameras all around them, and then the jumping in the room, so cameras can catch the image of them jumping from all angles, and this can be then replicated on a computer using software. Data can also be generated through 2D images, which have been taken by a camera. So an image can be moving or still, and although it is of a 3D person, it can only be viewed from one angle it was taken from. So it's 2D. An example of this is a basketballer jumping would be videoed by a camera and then create an image which is only from one perspective, which is that the camera took it from. So when generating a 2D video, the frame rate should be considered. This is how many frames are taken per second. It is measured in hertz. A greater frame rate would generate a smoother video. A high frame rate speed would be 100 frames per second. So an example of it being used to generate data would be a basketballer sprint drive. If it had a high frame rate, it would capture the quick movements, and you'd be able to see lots of different details of the drive. Shutter speed also needs to be considered when generating an image, as it's the amount of times it takes for the picture to be taken. A slow shutter speed may cause problems because it creates a blurry image. However, a fast shutter speed may not allow enough time for the light to get in. An example of this is if a biomechanist was analysing a basketballer shooting using a series of images, they would receive a less blurry image with a high shutter speed because the frames open for less time, so it captures the little details, but the image may be darker because there wasn't enough time for the light to get in. Horizontal scaling and vertical referencing needs to be considered when measuring data. Horizontal scaling is when the field of view is scaled so that all sporting action is included in the picture. Vertical referencing is the same thing but in the vertical axis. By using horizontal scaling and vertical referencing, the biomechanist would be able to ensure the distance and the space needed for the sporting performance is incorporated in the frame, which allows it to be an accurate method of collecting data. And as well as this, it provides a value. It will allow a value to be provided, so the details can be converted back into real life values. An example of this would be if a biomechanist wanted to collect data on the basketball completing a layup. By using horizontal scaling, they would be able to capture the whole skill and then calculate what point of the court the player should begin their layup, as they'd work out the distance it took them to do the steps. And by using vertical referencing, they would be able to ensure they captured the whole shot after the basketball had jumped, and therefore be able to calculate how high the player was jumping and whether that was sufficient for their shot. So perspective error allows the whole image to be accurately measured. The camera should be perpendicular to the performer because the changing position of it would change the angles that it's capturing. This is also the case when a performer moves closer or further away from the camera, as their size will change, and it's called perspective error. So when creating a video for analysis, the recorder will need to know how far the camera is away from the performance and ensure that the performer stays that distance for the duration of the footage so the perspective doesn't change. And it's also important for the camera to be in a relevant position to what they want to see, which ensures an accurate measurement. So for example, if you wanted to see the speed of a basketball at 25 metres into their sprint, you would have to station the camera in line with the point in order to get an accurate measurement. Parallax error refers to objects moving away from the optical axis of the camera. This is important for biomechanists to prevent, because if the camera was moved above or below the optical axis, they would receive a different reading. To prevent it from happening, they would have to ensure the camera is kept at eye level, parallel to the performance. Here's the data collected in the 20-metre static sprint. It will be analysed in 6.4. Here's my bibliography. Sorry it was quite long and all my words were jumbled. Yeah, cheers.